I ran my AI app for 3 months before I looked at the bill. 70% of those API calls were handled by the wrong model. I was paying GPT-4 prices to tell someone what 2 plus 2 is. Multimodal routing is how you fix it. Route by complexity, pay by complexity. This one change cuts most LLM bills by 60 to 70%. There is a 10 times price gap between the cheapest and most expensive frontier model right now. Gemini Flash, 50 cents per million input tokens. Claude Opus, $5. Same API format. 10 times the cost. This gap is your routing opportunity. A router is a decision layer between your app and the model. It reads each request, scores its complexity, and picks the cheapest model that can handle it. Think of it as a bouncer who only sends the hard problems to the expensive club. You've been routing everything through one model. That's your bill. That's the whole problem. And here's where it gets interesting. The fix is not complicated. So here's how a router actually works. Request comes in. The router scores complexity. Low score routes to the cheap fast model, Gemini Flash or Claude Haiku. High score goes to the frontier model, Opus, GPT-4, whatever your heavy hitter is. Same output channel, different cost. The router doesn't read your data. It reads signals about your data. Query length, keyword patterns. Analyze and compare route differently than extract and summarize. Conversation depth. These signals need no model call to compute. Microseconds, not seconds. UC Berkeley, Anyscale, and Canva built RouteLLM and published it at ICLR 2025. On standard benchmarks, it delivered 85% cost reduction while keeping 95% of GPT-4 quality. Let that sink in. 85% cheaper, 95% of the answers. 3 signals to classify a request. 1, input length. Anything under 50 tokens is probably simple. 2, verb fingerprinting. Analyze and compare, go heavy. List and extract, go light. 3, conversation depth. A 10-turn thread with context needs more horsepower than a first message. That's it. Congratulations. You've built a classifier. The router doesn't have to be perfect. It has to be right often enough that savings beat the cost of misroutes. At 80% accuracy across millions of requests, you're still winning. But the real numbers are coming up next. Enough theory. Here's the actual money. Here's the current pricing landscape. Gemini Flash sits at 50 cents per million input tokens. Claude Haiku at $1. GPT 5.2 at $175. Claude Sonnet at $3. Claude Opus at $5. The gap between the cheapest and most capable is not a rounding error. It's an order of magnitude. A real customer support platform. Tens of thousands of requests per day. They reduced their monthly LLM spend from $42,000 to $18,000 by routing simple queries to Claude Haiku and escalating complex ones to Sonnet. 57% savings. Same customer satisfaction scores. Before routing, every request hits your most capable model. Fast to set up, expensive to run. No insight into what actually needed that level of reasoning. After routing, simple tasks go cheap. Complex tasks go capable. Your bill reflects what you actually used. Here's the thing. Not everything should be routed to the cheap model. Legal documents, financial analysis, anything where a wrong answer has real consequences, those go to the frontier model every time. Your router needs a hard override list. Congratulations, that's your first engineering decision. The math works. 70% savings is not a best-case scenario. It's what multiple production teams report. The question is not whether routing works. The question is why you haven't built it yet. Now, how to actually build this? 3 steps. Step 1, audit your last 30 days of requests. Find the simple versus complex split. If 60% are simple, routing pays for itself fast. Step 2, pick a routing strategy. Rule-based if your tasks are predictable, classifier-based if they're not. Step 3, monitor your misroutes. Log routing decisions and check the first week. You will need to tune it. The analogy that makes this click: a post office sorting machine. It doesn't read your letters. It reads the envelope, weight, destination class, size, and routes accordingly. Your router does the same. Reads the request envelope, not the contents. 3 routing tools worth knowing. RouteLLM, UC Berkeley. Open source, drop-in replacement for the OpenAI client. Trained routers ready to use. LiteLLM. Proxy layer supporting over 100 models, including local ones. Rule-based routing built in. Portkey. Managed routing with fallbacks, retries, and cost dashboards. Good if you don't want to own the infrastructure. One final number: your router should add less than 50 milliseconds to each request. Most production implementations land between 2 and 20 milliseconds. 50 is the ceiling. If yours is higher, profile it before shipping. A slow router defeats the entire point. Here's the honest take. Route by complexity, not by habit. The frontier model is a specialist. Stop calling it for everything. Most of your requests don't need it. Your bill is proof. 4 things you now know. There is a 10 times price gap across frontier models right now. Routing classifies complexity in milliseconds with no model call. Production teams are saving 50 to 85%. And 3 tools, RouteLLM, LiteLLM, Portkey, let you add routing today without building from scratch. If this one landed, I put these out every day. Subscribe and the next one will be waiting. Next up, prompt caching. The other place your LLM budget is leaking that nobody talks about. Link to RouteLLM is in the description. Go build the router.